Yeah, water cycle. To understand hydrogeology, you have to understand how water move, how water occurs within rocks and stuff. Okay, so the sun provides with the source of energy, or sun act as a source of energy, which provide the sun rays or the sunlight to the to the surface. And then if the sun's energy hit the water will absorb that energy, and then the water will start to gain sufficient kinetic energy. All right, and then evaporation will occur. Then evaporation is a process wherein the liquid is being turned into a gas. Right now, because the warm air has a capability to have large volume, that is to say, to allow enough water vapor to be held. So warm air can be able to, it has got the capability to hold sufficient amount of the moisture. Whereas the cold air, it will hold less moisture. All right. So like I said, you can think of this as rubber. The rubber, if you take a rubber band, then you sink it within the water, the rubber will expand. All right. It means its volume, it has increased. But when it's cold, it will shrink, the volume, it will decrease. So you can think of that scenario. So the evaporation, a process wherein a liquid is being turned into moisture or water vapor. Then the air will be able to hold the water vapor or a moisture if ever it's warm. And then the air will rise up with what? With the water vapor in it. Then we know that anything that is hot, it's less dense. That's why it has got the capability to go up. Then again that the higher you go, the colder it becomes. All right. The higher you go, the colder it becomes. And then it means the water vapor will meet with the particulate matter, like that, particulate matters. And then when water vapor combines with particulate matter, they form a water droplet. All right, they form a water droplet. But when water droplets, they combine all together, they form a cloud. So a cloud is just like a container which is holding the droplets within. Then the droplets within, they can be held in suspension for as long as it takes, if ever the weight is reasonable. Now, this is like, you can now see these clouds. Evaporation, process wherein the liquid, they were turned into the water vapor or the gas. Now, what about a condensation? Now, the condensation, it will thus be what? A conversion of a water vapor or that gas into a liquid. Okay, so it means for you to form a cloud, remember you were having these vapors. You were having the vapor, they were rising, combining with now the particulate matters. They start to form a liquid. Now, it means these particulate matters, this vapor, it's a gas. It's a gas. So when it starts to combine with this particulate matter, the dust particles up in the sky, they form a water vapor. So it means you are converting this vapor into a water droplet, and then in a process called a condensation. And then when those droplets, they combine all together, they form a cloud. So it can be said that a cloud, these clouds, they will be formed by a process of condensation. All right. And then these clouds, they can now be transported. They can be transported. And then when they get to be transported is because remember, during transportation, there won't be any rain. Why? Because it is assumed that the droplets within the cloud, they are being held in suspension. It means the weight is still reasonable that the cloud can be able to hold. All right. But as soon as these droplets, they get to be heavier and heavier, then the cloud can no longer be able to hold these droplets. It will release these droplets. And then when the clouds release the droplets, it's a precipitation. It's a precipitation. So precipitation is when a rain is pouring. But now, evaporation, it goes hand in glove with transpiration. Transpiration is wherein the trees, they receive sufficient amount of energy, and then they release water vapor. And the leaves of a tree, remember the leaves has got the water within, but when they receive sufficient amount of sunlight, of energy, they will now release what? They will also release the water into the atmosphere. So also, but now when water is being converted into a vapor, or a liquid being converted into a vapor, but from the trees, the process is transpiration. But when a liquid is being transported or converted into a vapor in oceans or in any body of water, we call it evaporation. So now we are still here at precipitation. The rain is pouring. If the rain, it now find vegetation, plants, the grass on at the earth surface, like these plants, the water, the vegetation, they promote absorption. What do we mean? We mean if there is too much of grasses, the water won't run too much. There won't be too much of runoff. If you can if you can see a lawn in your respective homes, at any places wherein you've planted a lawn, there won't be too much of evaporation. Rather, no, there won't be too much of erosion, but there will be absorption. But in the places wherein you don't have vegetation, there will be erosion. Okay. Now, the water that is falling into the earth surface, it can either run off or precipitate. All right. Precipitate, it can sink. Then why does it sink? This is because the soil, it's porous, it's permeable, wherein the permeability deals with a soil having pore spaces, wherein those pore spaces are interconnected. What do we mean when we say they are interconnected? We mean those pore spaces, they are interconnected, and they allow the water to flow without any further disturbance. Okay, now that's where the precipitation, a rainwater, can infiltrate into the ground and recharge the groundwater, or refill the groundwater. Okay, then the runoff, this rain, this water can now flow, okay, into the surface as a surface water. In dam, it can now flow in rivers or be stored in dams, you know. And then even when it's in dams, it will still infiltrate. This is because the The rocks, they are porous. They allow the infiltration. But remember that the surface water is any water that is occurring at the surface or above the surface. That is lakes, the dams, rivers, etc. Okay. Now, but if you have got the between the surface water and the groundwater, you have got the porous rocks, the rocks which allows infiltration. The rocks which allow infiltration. If the water gets here, it can be able to pass through. If the rocks are porous, this surface water can be able to recharge a groundwater. That's why you see a groundwater. The surface water can be able to recharge a groundwater. And then the groundwater, it flows depending on the slope. If now the slope is steeping this way, that's why the groundwater flows until they recharge the ocean. Okay, so in hydrogeology, you'll be exclusively focusing on how this will be the study. Hydrogeology is the study of the distribution, the occurrence, the movement of the water within various rocks, depending on the porosity of such rocks. Wherein the porosity can be formed by geological processes, such as faulting, such as folding or tectonic deformation, folding, weathering, the list is endless. All right. Now, we know that when we say you have got the fold, when we say we've got the fold, we now see that, oh, the fold, it allows the passage of the water. If you have got the folding is wherein you have got a rock and then there is directed pressure, making these to bulge like that. And then as it bulge, it creates the planes of weakness or the folds or the fractures. So can you see that deformation or tectonic deformation? You are deforming a rock. By so deforming the rock, you are forming some fractures. And within those fractures, it's wherein the water will be able to occur, move, and also be distributed. All right. And then weathering is wherein you are breaking the rocks. You are breaking the rocks physically, chemically, and the biologically. Biologically, it's wherein you're having the worms burrowing, worm burrows. Okay, they're creating some channels. That's where you can take the rock which was firmly compacted, making it to be loosened by what? By those worms. Then the chemical weathering, it's example wherein you are using water to break down the rock. Okay, like the process called hydrolysis. Hydro means water, lysis to break. You are breaking the rock using with the aid or the help of water. Okay, and then the physical, for example, if you have a rock and it has got a little fractures like that, and then the water can be able to fill within these fractures. Now there get to be a freezing. then when the ice occurs within these fractures, it will make these fractures to widen a little bit. Okay, but now during the night it will form an ice. During the day, the ice can be loosened. So that expansion and shrinkage of the ice, it causes weathering. Okay, even the roots of the tree, when they percolate or they try to run through the rocks, they break the rocks. So in hydrogeology, we're going to all exclusively and entirely be focusing on how these faults, how these fractures, they help South Africa in storage of water. For example, a sedimentary rock, we know there are the rocks which are likely to be porous, right? Some of the rocks, they get to be naturally porous. Example, sandstone. But think of an igneous rock, a granite, highly solidified without pores. Then, but what will happen for a rock to be able to store water? For example, a bushveld, Leboa granite. It means for Leboa granite to be able to store water, it means tectonic deformation must take place. You must deform a rock first. The tectonic processes must occur on that rock so that we create our own fractures. So in hydrogeology, we're going to be looking at that. Any question? All right. No problem. Let's move. But to understand water cycle, you have to understand how South Africa is situated. Okay. South Africa is sitting within what we call a plateau. That is to say, South Africa sitting in something like that, where in here there is an ocean, and here there is another ocean. Yeah. Now we call this flat area, which we call this a plate. Plateau. Okay, the flat area. That's where South Africa is situated. South Africa is it is bordered by what you call the left and the right escarpment. Okay. Now, here is ocean, and here is also an ocean. Do you know what the difference between the Indian Ocean and Pacific Ocean? All right, but it's fine. It's fine. It's fine. What you should note is on your right hand side, that's wherein you find the Indian Ocean. Okay, so here is the ocean. Also, here is the ocean. So here is an Indian Ocean. Indian Ocean. Right? But now, if we have got the Indian Ocean, so what will happen is during evaporation, the liquid will be converted into water vapor, like the manner in which I've discussed this water cycle. Then the vapor will be carried by the air. If the water or if the air is warm, can be able to carry sufficient amount of the water vapor. All right. Now this would rise, this would rise, this would rise, this would rise. Remember, here it's Pacific Ocean. Okay, Pacific Ocean. Now, rather no, sorry, Atlantic. It must be Atlantic, not it must be Atlantic, because I'm not looking exclusively on Africa. All right. So here it's Atlantic Ocean. Atlantic Ocean. So this one is cold, this one is warm. Okay, you know, we have what you call the warm Benguela, the cold Benguela. Okay, so these are also the typical of grade 12 geography questions, because they fail to understand. Remember, in science, if you don't visualize these things, you may not be able to understand them. So this is Indian Ocean and Atlantic Ocean. All right. So we want to understand why South Africa it has got so much rain in winter, no, in summer, but less of rain in winter. Why is that so? This is because we've got what you call the layer of inversion. We've got what we call an inversion layer. We've got what you call an inversion layer. We've got what you call an inversion layer. Guys, do you know what is called an inversion layer? Is it for the first time you hear the word an inversion layer? Guys, is it for the first time you hear the word inversion layer? All right, but it's fine. It's fine. So an inversion layer, we can try to type. It's a layer. An inversion layer. It's a layer of the what have I done? It's a layer of the atmosphere. Layer of the atmosphere in which the temperature increases with height. Okay, in which the temperature increases with height. A layer of the atmosphere in which the temperature increases with height. It means the temperature it increases with what? With height. But why do we say it's a conversion layer? All right. So what is happening is, let me shift this a little bit. Yeah. So what is happening is, as this water vapor is being, moved upward, being carried upward. So in June, the inversion layer is somewhere below the escarpment, somewhere here. So when the vapor rises, it hits this inversion layer, then the water will come back into the body of ocean. So it's like they are in circular equilibrium. They are in circular equilibrium. So this inversion layer, it creates an equilibrium between an ocean and it. So you cannot have too much of the vapor reaching the escarpment in winter. So in winter, the escarpment, or rather the inversion layer, is just a little bit below the escarpment on your right. That's why the vapor cannot reach the escarpment in winter. So, which is why, and we know that if we don't have a vapor, we cannot form a cloud. And then if we don't have a cloud, we cannot form a rain. That's why in South Africa, we don't have enough rainfall in winter. So that's in hydrogeology. We know that in winter, the recharge of groundwater, the groundwater is being it's dropping because the recharge is weak. Why? Because the rainfall, which act as a recharge, it's down or it's low. But in summer, the escarpment it moves here. Let me show you. In summer, the escarpment it moves, not escarpment, but the inversion layer. The inversion layer in summer, it has this. It moves a little bit higher. It moves a little bit higher than the escarpment. Now the vapor, it will be able to rise, being carried within the warm air. Okay. Now, can you see what the vapor will be doing? Now it can be able to reach the interior side. All right. Now it means the clouds now can be able to form there. The clouds can be able to form, the clouds can be able to form, the clouds can be able to form. Then when they form, then the precipitation can be able to occur. Precipitation can be able to occur. So that's why South Africa in summer, it receives sufficient amount of water in summer, of rainfall. Why? Because the inversion layer, it went a little bit higher above the escarpment. So this is to sum up, this is effect of topography on the South African rainfall. Right? We still have got the effect of latitude. That is to say, to tell you that I can just introduce a topic a little bit, but South Africa, if this is the equator, South Africa is somewhere here. So the regions which are closer to the equator, they always receive sufficient amount of rainfall, right, than the regions which are far away from the equator. So this also has got the effect, and I'm gonna do it shortly. Until now, let me ask if you guys have a question about the water cycle, and also how does the water cycle get to be affected by the topography of South Africa. Why are we having rainfall in winter, which is less, but more rainfall in summer? So that is the effect of South African topography. That South Africa is sitting, or we as South Africa, we are within or at the escarpment. Or not, no, within the interior of the escarpments, the left and the right. We are here at this flat region. We call it a plate or plateau. So South Africa is here. That's why we are suffering with respect to rainfall. So South Africa generally does not have high rainfall. Rain does not pour throughout the year. So these are some of the things as scientists that we must look into consideration. So we can study these things to help South Africans to know or to be able to, save water. They shouldn't pollute water because water is scarce. Water is scarce in South Africa. It's very scarce in South Africa. water scarcity, it's a challenge in South Africa. Okay, so that's why we must make sure that we don't, there are some people who are irrigating their plants during the day, where in the rate of evaporation and transpiration, it will be very great. Then why are you doing that? It means you were not being told of how we are suffering in South Africa. Okay, so without any waste of time, thanks for being here.